to go over. So I'll just start with 5.5, 6/3. 5.5, 6/3. 5.5, 6/3. First of all, is it a test question? It is a test question, but I'm going to rewrite it to where you can understand it. Because the way they've got it written, you don't even understand, and you probably know how to do it. You just don't understand what they're asking, which is normal in this book. What are the new limits of antiderivative from 2 to 8 f of x dx with u substitution of u equal to x squared minus 6. That's the way it should be written. Now that is a test question. So what you need to do is you need to make sure you make a note of this question and say, what are the u values of 8 to f of x dx when u is equal to x squared minus 6? So your lower limit is equal to parentheses squared minus 6. Your upper limit is equal to parentheses squared minus 6. And your lower limit's 2, your upper limit's 8. 4 minus 6 is negative 2. 64 minus 6 is 58. Now see, I bet you $1 there was 2 or 3 people in here that looked at that problem and didn't know how to do it. But then when I did it, you went, oh, I know how to do it. So let's go back to and type in a negative 2 and a 58. So whoever sent this question, don't feel bad, because the way this book writes questions, sometimes it takes a Philadelphia lawyer to understand it. All right, let's see what the next one is. That was 5.56, so I'm going to delete that one. Let's see, 6.3. Okay, we got 6.342/5. 6.342/5. Is it a test question? Yes, and we have done this one before, and it's in the videos. But I will do it again because y'all don't watch the videos. So. And if I just did class and didn't do videos, you know what y'all would say? You ought to record your classes and put them on YouTube. That's what y'all would say. So, I ought to stop doing the videos because all it does is take time to do. But as soon as I do, y'all start hollering. Even though only 4 or 5 of y'all watch them. Y is equal to e to the x. Y is equal to e to the negative x. In fact, I think we did this exact problem, except the natural log was different. I think it was like natural log of 8 or something. Somebody look in your notes and tell me if we did this problem. X is equal, is either the natural log of 5 or the natural log of 8.
I'm pretty sure it was the natural log of 8.
So we did do it. Yeah, I don't expect y'all to watch videos. You know, you have to go through all that work of hitting a button. You know, it's real tough work. So, of course, what's the first thing I'm going to tell you to do on this one?
Sketch.
First thing, draw a graph. First thing I tell you on everything. And like I said before, you better get used to it. So I'm going to take my handy dandy yellow pen. And that's going to be that one. Blue pen. And my pink pen. And you can take your orange pen. X is equal to 0 is the y-axis, so you could do that if you wanted to. And here is your area that they're wanting. All right. So I guess we need to set up our pi and our, that's going to be v is equal to pi 0 to the natural log of 10 of e to the x squared minus e to the negative x squared dx. Now I'm going to give y'all 3 minutes to do that calculus and algebra and math. So handy dandy timer. And 4 minutes. Take off. Impress me. And if you can't do it, we'll just write it up as you being a failure. They done stuck Miss Levy in a closet. Them people done got mean. They got mean and put her in a closet. What kind of people you working for, Miss Levy?
I just moved into the break room because I had to charge my laptop.
That is a very festivus, I don't know what you call it. That's very interesting break room. It's very exciting. Looks like a closet. Well, as long as you're not in trouble. We thought you might have been locked up in a panic room or something. There's a lot of math in there, so that's why I gave you 4 minutes. Of course, most of y'all probably quit by now. Why? Why do you think some of y'all quit?
Because it's too hard.
Because it's too hard. It's e to the x. It's e to the x. That's, might as well say, a fraction. I bet Mr. Paris has already quit. He's out pumping gas or something. He's at the QC.
No, the trick is just to never start.
Oh, never start. Okay. Just act like you're doing it, right? Draw the little squiggly lines and act like you're doing it. Okay, 45 seconds. That's good. All right. So that's going to be v is equal to pi from 0 to natural log of 10 of e to the 2x minus e to the negative 2x dx. And I'm going to take my handy dandy pink highlighter, not pink pen, and I'm just going to remind everybody about those parentheses right there. Just like we did last time we did this problem, I put parentheses around that 2x and that negative 2x. So the antiderivative of e to the 2x is e to the 2x over what? 2. Minus e to the negative 2x over negative 2. Evaluated at 0 and the natural log of 10. And the only other thing we can do before we can start is what happens to those two negatives?
They turn into a positive.
Yep. So your setup, well, actually, this is your setup. Okay. But the actual starting to plug and chug is v is equal to pi e to the 2x over 2 plus e to the negative 2x over 2 evaluated at 0 and natural log of 10. And we're going to go to the next page with that. So I'm going to put this on the whole. There we go. Therefore, the 1 or 2 people that do watch the videos can actually pause it. And let's plug and chug. Now, of course, I'm doing this step by step. I know half of y'all probably skipped to the end, even though you probably got it wrong. Pi e to the 2 parenthesis over 2 plus e to the negative 2 parenthesis over 2 minus e to the 2 parenthesis over 2 plus e to the negative 2 parenthesis over 2. And your upper value is the natural log of 10. And your lower value is 0. Well, why didn't I cross 0 out like I always do? Because here, e to the 0 is 1. And you can't cross it out because it becomes a number. So that's going to give me v is equal to pi. That's going to be e to the 2 natural log of 10 over 2 plus e to the negative 2 natural log of 10 over 2 minus 1/2 plus 1/2. V is equal to pi e natural log of 10 squared plus e natural log of 10 to the negative 2 minus 1 . Can somebody tell me what I did from here to here? What rule of exponents or natural logs? What rule did I use from here to here? Starts with a P.
Power rule.
The power rule.
Of natural logs. Power rule of natural logs or logarithms. And what happens to e to the natural log? What happens whenever you have e and the natural log beside it or up to it?
They cancel out.
Yep. V is equal to pi 10 squared over 2 plus 10 to the negative 2 over 2 . (100 over 2 plus 1 over 200 . Got to get a common denominator. So that's going to be 200 over 200. Put 200 right here. 100 times 100 is 10,000. So V is equal to pi times 10,001 over 200 minus 200 over 200. $10,000 minus 200 is 80. What? 80, so it should be 10,001. 10,000 minus 200. 9801, that's what I thought it was. 9801 pi over 200. Now, why is this a good test question? I want you to think like a teacher. Why is this a good test question? Because it will make you quit and make your grade go down? Yeah. But why would I pick it besides that? It has calculus. What else?
Algebra.
Algebra, and what else?
Fractions.
Fractions, which is arithmetic or math. Which half of y'all probably quit about halfway through the problem. $98.01 pi. $98.01 pi divided by what? 200. And we feel good about ourselves. All right. 6.3. I think this is it. Six point three 45/6. 6.3 45/6. Write this down as 2 test questions because it asks you to do 2 different things. So it's 2 test questions. I wouldn't ask you to do the whole thing. I'd ask you to do both of them for 2 test questions. In other words, it's a good test question, but not together. For the region bounded by y is equal to x, the x-axis, and x is equal to 2, so let's draw that. Y is equal to x, x-axis, and x is equal to 2. Find the volume around the x-axis and find the volume around the y-axis. They're going to be more, one of them's going to be more detailed than the other. So I'm going to draw a picture. Y is equal to x is a 45-degree angle. So I'll color that orange. And the x-axis is right here. And I believe that's supposed to be x is equal to 2, but I'm not writing it correctly today. So x-axis is yellow. Bring in the blue. X is equal to 2. There you go. So go ahead and do around the x. So A, find the volume around the x-axis. And then B, find the volume revolving around the y-axis. I'll give y'all a few minutes to set them up. And just get to the setup and then go to B. I'm not worried too much about it. We need to work the math together. Get to the setup on A and then do the setup on B. Give you a couple of minutes. So we're going to go from volume is equal to pi from 0 to 2 of f of x squared dx. Because if you do around the x-axis, you're only talking about a disk. So you're talking about, for A, you're talking about the cone-shaped cup. That's what it looks like. So v is equal to pi 0 to 2 of x squared dx, which is equal to x to the third over 3, evaluated at 0 and 2, multiplied by pi. And of course, 0 goes out. So that's going to leave 2 to the third, which is 8/3. And that's going to be 8 pi over 3. So that's the volume with it going around the x-axis. Now I want you to find the volume going around the y-axis. But you got to be careful because there's several things you have to do when you go around the y-axis. For one thing, you have to make sure when going around the y-axis, one, you have to make sure that f of x is in terms of y. In this case, we're okay because what does y equal? X. So x is equal to y. So you really don't have to do anything there. But if you did, you would have to solve for x. You would have to solve for x if it was like y is equal to 2x, or y is equal to 4x, or y is equal to x to the 5th power. You would have to solve for x since it's revolving around the y-axis and solve for x. But we don't have to do that here because that's x is equal to y. Okay? 2, what do you have to do next? You have to convert b into d. Okay? In a to b, or x, when you're revolving around the x-axis, you go from a to what? A to b. When we're in the y-axis, you go from c to what? D, Hubert. So you've got to convert that the x that you've been given, which our x is what? 2? Somebody tell me what y that is for d. Somebody tell me what d is.
Would it be 2 as well?
No. Well, yeah, I'm sorry. It would be 2 because y is equal to what? X.
X.
What if it was 2x plus 4? Well, you'd have to plug that 2 into 2x plus 4 to get that d right there. And all of you need to write that down because you have to do that. Okay, you have to convert your b into d by plugging in x into your original function. And then 3, again, make sure you solve. Oh, no. This right here, that's your what? Well, let's draw it. Take my orange, or let's go with green. Well, that green you're not going to be able to see. Let's go with this green and a purple, a magenta. You're revolving around this axis. So this is your outer what? Radius. And somebody tell me what this is. If this is your outer radius, what is this? Okay, remember, It's a washer. So remember that your outside radius is usually going to be right there. So you're going to do your outside radius minus your what? Minus the inside radius. And they both have to be in terms of y. Now those are the three things you have to remember. Now we've already went over this. It's in the video. You got to do these three things when you're talking about the y-axis. So let's start. First of all, I got to make sure, well, it is x is equal to y is equal to x. So I can just write y right there. That's my height. My radius is equal to the function. So I just got to multiply. My height is going to be that right there, which is 2. And we're going to subtract x squared, or not, in this case, x. It's going to be x squared. So v around the y-axis is equal to the height, which is radius, the outside radius right here. That's going to be 2 minus x squared dx from 0 to 2. From 0 to 2. V is equal, oh, don't forget the pi, from 0 to 2 of 2y, that's supposed to be y also, minus y squared dy. And that's going to be pi times 2y squared over 2 minus y to the third over 3, evaluated at 0 and 2. And that all together, that's the setup. Well, after the setup, this is the actual setup. This is your setup for calculus. This is your setup for plugging and chugging, basic math.
Yeah, but could you just go over how you got the 2y again?
What's the, I'm sorry. I think 4y. Because 2 squared is 4.
Okay.
I took the antiderivative. Well, I guess I'm just crazy. It should be 4y. The derivative should be 4y. I'm sorry. I got the cart before the horse. 4. And then that should be 4y. I'm sorry. 4y minus y to the third. Yeah. Minus y to the third over 3. Sorry about that. So you get 4 minus y squared, and then take the antiderivative, which would be 4y minus y to the third over 3, evaluated 2 and 0, multiplied by pi. So I'm going to write that on the next page. Pi times 4y minus y cubed over 3, evaluated at 0 and 2. And the 0 pretty much takes out itself. So that leaves us with pi (4 times 2 minus 2 to the third over 3 pi 24 over 3 minus 8 over 3, 16 pi over 3. And that is more detailed, more accurate than around the x-axis. Okay, so that'd be 16 pi over 3. So that was, the first one was what? 8 pi over what? 8 pi over what?
8 pi over 3, I believe.
Over what?
3.
And then this one is 16 pi over 3. And the volume around the x-axis is greater. Y-axis is greater. Now, there's 2 good test questions right there. Do this around the x-axis, do this around the y-axis. So each one of those are two good test questions. I probably would not give you this on the test. If I did, I would take one question off so you'd have more time to take it, because it does take a little bit extra time. And that is the homework questions for today. Now, let me show you what we're going into today. And I don't have much time, but we can go over it. And that is shells / ring. I call it the ring, but you can call it a shell. Let me see, where's my page where I'm actually showing you all this stuff? Hold on a second. Well, there they are. Okay. I wish I could draw with the old, let's see. Hold on a second. Where is my GPS? There it is. And the difference between a disc and a washer and a shell this right there, this right here is a shell. Okay? That is a shell on the bottom. It's revolving around the y-axis, and that is a shell. This is a washer. This is a shell. It's kind of like the difference between the two. Let me try to show you another one. There's one. There's a shell right there going around x is equal to -2. And that's your washer. There's a shell. And there's just there's a difference, kind of like the difference between your leg and an arm. I mean, the shell, you got your disc, you got your shell, washer, and then you got your shell. I like to call the shell kind of like a ring, because when you see it, and you draw, let's see, this is the function. and you draw it, and I'm going to try to do it real small. There it is. And then when you draw it, it looks like a ring. If you're looking at it from like that, it looks like a ring. And that's why I call it a ring. And of course, if you did it all the way around, you'd have this function right here would look like a bundt cake. And I'm not even going to try to draw a bundt cake because I can't draw. So what I do is just show you what a bundt cake, because I doubt very seriously, since y'all are in the D Generation X or whatever y'all, Z Generation or whatever, I doubt very seriously you know what a bundt cake is. So I'm going to just show you right quick. BUNDT I'll tell you what, bundt mold. Bundt cake mold. There it is. So it looks something like that right there. That's the bundt cake mold. And it disappeared. Yeah, I shouldn't have clicked on it. There it is right there. So that's what you're looking like as far as a 3D object. It's not perfect, but it's gives you an idea. All right. So that's a bundt cake. So this function using this shell method going around and around and around is pretty much going to make a bundt cake shape. And I'm not even going to try to draw it. Now, what are the big differences between a shell and a disc and a washer? Well, the big difference is you're going to be multiplying by 2 pi. Okay? And that's because, oh me, I'll be glad when summer's over. So sick of July and August. Okay. So the volume is going to be equal to 2 pi a to b of r of x, which is your radius, times your height. Okay? Your radius is right here. Radius is equal to x. So as this guy travels, your radius, this is your radius right here. Radius is equal to whatever x point that rectangle is at. If it's right here, then x is your radius. If it's right here, x is your radius. So the radius is going to be equal to x. And x will always be in your shell equation. X will always be there because x is the radius. And the height is equal to the actual function. The height is equal to the function. Everybody with me? Now, the only other thing I want to throw in here is if you have another function here, then you're going to have to subtract f of x minus g of x for h of x for your height. So if you have two functions, you got to find out your outer radius minus your inner radius and subtract them, just like we've been doing. Okay? Now that's revolving around the y-axis. And this is a shell. Remember, this is not a disc and it's not a washer. This is a shell. It's just one rectangle that goes round and round and round and round.
So is the difference that it's not touching the y-axis? Is that
That's
what makes,
it. That's the difference. Yes.
is that also why you're multiplying by 2 pi? Because you're
Yep.
going.
Well, the circle, yes. Yes. All right. Now, what if you go around the x-axis? Well, I'm going to be honest with you. You don't go around the x-axis very much with a shell, but you can. All right. If you go around the x-axis, it's going to look like that. Okay. And like I said, it's not usually done that way. Okay. But you can go around the x-axis. And in that case, it would be volume around the x-axis is equal to 2 pi c to d. And this is c. D would be up here. R of y times h of y. Now remember, now this is a disk. I mean, this is a shell. And if the shell goes around the x-axis, you got to put everything in terms of y. It's kind of like the opposite with the disk or the washer. Okay? So you got to remember, with a shell, when you are revolving around the x-axis, you have to treat it like you're revolving around the y-axis, and you have to get y. You have to get the equation in terms of y, the radius in terms of y, and you have to do everything in terms of y. So that's with a shell. With a disk, you do it when you're revolving around the y-axis. So make sure you make this distinction in terms of y, like disk revolving around y-axis. Okay? So when you're doing a disk or a washer, you have to do in terms of y when it's around the y-axis. When you're talking about a shell, you have to do it when it's around the x-axis. You have to get everything in terms of y. And that's just because that's the nature of the beast. It's because the way it's, I mean, if you sit there and look at it, the height right here, your height right here is going to be equal to your radius. So that's in terms of y. So here's your radius right here. That's your radius. Your radius is in terms of c to d. And your height is going to be your actual function. All right, it's a whole lot easier when you look at a, just trust me, when you look at a example. If I can find one. Here's one. And this is a test question. Why? Let me clean this off a little bit. Why is equal to x minus x cubed. Y is equal to 0. X is equal to 0. And x is equal to 1. And you're revolving around the y-axis. All right, now, of course, the first thing you should do is what? Draw what? Draw a picture. Hubert. Draw a graph. Hubert, sketch a graph. Yeah, that's right, class. Thank you for communicating. Y'all suck. I'm going to give y'all a minute or two to set it up. Excuse me. And Mr. Paris is going to present it as he's driving down the road.
We're all gonna fail. Don't worry.
What?
I said in that case, we're all gonna fail. Don't worry.
Yeah, I know you're going to fail. I told you that the first day of class. So, I would say we got a, and I would say probably you're talking y is equal to 0, or the function, this right here, x, that's negative, so it's concave down. So I'd say it looks something like that. And we've got a x is equal to 1. That's going to be right here. X is equal to 0. That is right here. And y is equal to 0 is right there.
Wouldn't the graph of x minus x squared, wouldn't that go under the axis?
Did you graph it?
No.
Exactly. See, you don't do anything. You just raise all kind of heck in my class. That's all you do. Let's see. Clear. Clear. Hold on.
No, I was just plugging some numbers in.
Hold on a minute. I'm too busy graphing on my calculator. but you didn't do it. All right, x minus x cubed. There it is right there. See it?
Yeah, I thought it said x squared.
Oh, okay. Now don't just ignore that red line because that's not even in there. Okay? I could, but I'm not going to worry about that. But there it is, the yellow part right there is what we're dealing with. Okay? So we're revolving around the y-axis. Which is usually the way that you do a shell. So it looks, looks like the one we just did for an example. You're going to be going around like that. So this is your r is equal to x. And then the height is going to be equal to the function. So plug and chug, v is equal to 2 pi from 0 to 1 of x times x minus x cubed. There's the setup. Now you do it. It's actually not very long. In fact, it's about short. You only have to do a couple of things. So go ahead and do that calculus, algebra, and math.
Hubert, I have a quick question.
What is it?
So is only part of the radius x, or is it that whole curved line?
The radius goes from here to here, here to here, here to here, here to here, here to here. There's 50,000 radiuses in between here and here. It's infinite.
Okay.
So that's where you have to take that into effect with the antiderivative.
Okay,
X
and that's
is equal to the radius. You may have a radius right there. You may have a radius right there, radius right here, radius right there. This integral takes that x into account from 0 to 1.
okay. That makes
So
sense.
you may have 5,000 radiuses in there. You may have 500,000. The integral will take care of that. Because remember, this right here is the width of a hair. So how many width of a hair do you have between 0 and 1? A lot.
Okay, I see what you did now. Thank you.
So that's going to be v is equal to 2 pi 0 to 1 x squared minus x to the 4th dx. And that's going to be x cubed minus over 3 minus x to the 5th over 5 evaluated at 0 and 1 multiplied by pi. 2 pi. Multiplied by 2 pi. Now 0 takes itself out. And that leaves you with 1/3 minus 1/5 times 2 pi. And a 15 here and a 15 here. 3, that'll be a 5. 3. 4 pi over 15 is what I got. That right there is a test question. I'm going to leave it up there for a minute or two because that's the kind of question I would ask you for a shell.
So where does r equals x come from? Is that a given? Is that something that will be
Yeah,
given?
that's something I told you at the very beginning, yes. R is always going to be equal to X when you revolve it. Think about it. What is that R doing? It's starting here, and it's what? It's going to 1. So whatever that, wherever it is, I want you to see that. The radius of this thing is equal to what? Where it is on the x-axis. All right, that's enough for today because we still got some more problems to do. So we're gonna end with one shell problem. There it is. So let me go to the handy dandy attendance.